Thank you so much for joining us.
My pleasure.
I don't know if you want to start by telling us a little bit about yourself and about your work at Google. That would be amazing.
Sure. I'm Ivy. I'm currently working on agents for science at Google Research. And in fact, we just launched at the I.O. There's this big umbrella term called Gemini for Science, where we launched a joint effort of different projects that are all on the same purpose, which is Gemini for Science. And it's a list of tools and products for science researchers and scientists. Yeah.
Amazing. I know Google has recently launched a lot of tools. So what is actually new versus what has been quietly
100%.
running internally?
Yeah, so I would say can't comment on what's happening internally, but I would say the difference and the why the recent launch are critical is that first of all we have some products that are accessible by external researchers. We actually have literature search tools, for example, for researchers to retrieve relevant papers that are going to be really beneficial for their own research, a tool for literature search, and then another tool, which is what I worked on, is called computational discovery. Mm-hmm. So that tool is more like a tool to help improve the efficiency and throughput for researchers, which is essentially it helped us a lot of parameter search, help you to find the model that could produce the best score. And you decide on the data set, you decide on the eval. And we actually have users, researchers who are using this already, and we are getting a lot of positive feedback saying, okay, they are wishing to have such tools for them available, and it's finally available, and they're benefiting from it. So I think that's the comments of what has been launched at this I.O. Previously was a lot of I would say models and different things. For example, AlphaEvolve, AlphaGo, and AlphaFold for different verticals under the science umbrella. And now it's more, what's been launched is more like general purpose, which I think is awesome. And it's slowly rolling out to external users. And you should definitely check it out and try it.
For sure. So what is your take on the current state of AI for science right now?
Yeah, 100%. I feel like I mentioned, there are individual models that are performing really well. For example, AlphaFold for protein. I'm not an expert in that, but I know that it has been received really well, and the model came out a while ago. Definitely not Reason. And then there's a specific model in specific vertical, AlphaFold, AlphaEvolve, AlphaGo, and then AlphaEvolve is for, I would say, more general purpose parameter search, and that has also been out. But I don't think those models are as accessible to the general researchers as the product has been launched this past I.O. are. Going back to your question about what is the current state, so I guess, first of all, there are some already good, well-performing models for specific verticals. Second of all, there are a lot of exciting products being launched that are more accessible to general researchers compared to the highly specialized models. Those are more for general purpose science discoveries, and they're more accessible, right? However, I would say there's also agent and AI agent does not work wonders 100% of the time. There's still a lot of improvements people are investigating, and which would help the scientific researchers in general once we have those challenges adjust and sort it out. So if I have to give a description, I would say there's some really good, well-performing models. There's rolling out more tools, more accessible to general researchers, but also there are critical challenges that needs to be addressed for this to actually help our scientific researchers to a great extent.
Yeah, got it. I also heard that you mentioned general purpose agents versus AI for science specifically. I just wanted to hear, can you elaborate more on, like, for example, what makes scientific tasks fundamentally harder than, let's say, like coding or document tasks, things like that?
100%. There are many different aspects to this. Give an example. If we were to compare agents for software engineering, for coding tasks, right? I think that's really easily verifiable. Like, you can see if the agent produced code can be compiled, if it can produce a right output. It's pretty much straightforward with a much shorter feedback loop versus agent for scientific research, where it's like sometimes it takes a long while to even gather the data set and the training data set and also eval, right? Like, sometimes even it takes longer to gather those data sets, not to mention have some good starting models for specific scientific problems and like coming up with the eval. Like all those are not like close end as if we were to compare scientific problems versus general purpose coding tasks. So longer feedback loops, a lot of open-ended questions, and I think, yeah, those are a couple of the key differences between the two. And then on top of that, I will also argue that agent for science really care about specific things like factuality. Agent, like having LM hallucination might not be as much of a big problem for general purpose coding tasks, because it can be addressed, it can be fixed really fast compared to like for science, because sometimes the agent can do different things where including but not limited to, the agent can find different ways to cheat, like data leakage, modifying the underlying Python library so that it can score better. And those are like, I would say sometimes harder to spot compared to like a compiling error from like a software program produced by agent. So yeah, there are definitely different levels to this, different aspects. Yeah.
Got it. Those are great insights. In addition to those points that you mentioned, are there any other challenges that AI for science are facing?
Yeah, I would say the first thing that comes to mind would be general purpose agent harness versus specific vertical scientific problems, like harness for those specific verticals. I feel like I'm not an expert on any of the specific science field. I'm more like a CS or like AI person. But I think if we were to think about if we were to improve on the general, maybe like reasoning capability of the general purpose foundational models, it might not be it might not be trained. A better way to phrase this, I guess, is that if you were to think about doing like different ways to improve model performance on the reasoning for specific scientific verticals, it's even hard to think of like what kind of data to gather to do those fine-tune like post-training tasks, because the format and the format of the data would be 100% dependent on the problem. And you could say that there are some common ground, but I think it's gonna be different, yeah, and hence difficult to even get the data to fine-tune a model for specific scientific verticals. Yeah.
Got it.
Yeah, and then eval is also a problem.
So facing all those challenges, do you have any ideas on like how to address those, or in your workflows, are you having all those thoughts, or if you can elaborate more on that?
100%. I would say, given the example that LLM could sometimes cheat in different ways, right? Like, for example, overriding Python library so it could score better for scientific researchers. I would say one way is to like catch it early, because the reason why it could find the different advanced or not so advanced ways to cheat is that the reasoning capabilities are already good enough, and it sometimes just finds so much different routes to create ways that it could have a better scoring at the end. So how you can address that is you first need to catch it, like when it cheats, and sometimes it's hard for humans to go through examples one by one. So in that case, we should implement like LLM as a judge to catch those cases, and like basically you can just give the LLM like a rubric to say this behavior is cheating, this behavior is another example of the cheating, or things like that. So then the LLM can just digest that and actually like catch it where it cheats. And then having those data, then you can try to think about like maybe how to translate that kind of data, where it's like you have data or like a multi-term and like multi-term conversation history between like a human researcher and a science agent system. You can have that data, and you can have the LLM as a judge's data, like rubrics and the verdicts, right? Does the LLM judge think that cheating happened from the raw data and the rubrics you gave it? That's two different types of data already, and you can maybe consolidate the data that you have and then process it and use that kind of data to teach the language model, like what's the right thing to do. I think that could be used for different methods, like supervised fine-tuning or like reinforcement learning with human feedback. I think those are all possible, even though I haven't done exactly what I just described. But I think there should be ways to address that specific problem of like catching when the LLM is cheating and then teaching it to not cheat. And then I think the answer to the question of like how to address that kind of challenges would differ based on the specific vertical of the science problem as well.
Makes sense.
Yeah.
Thank you so much for sharing all those technical insights. We're so lucky to have you here. So I do have one last question. What is your hot take on the development of AI today?
Sure. Just my personal hot take, but I think a lot of the times general public have access to a lot of AI demos per se. Those demos are cherry-picked demos that works well, but it's not equivalent to the state of the reality per se, because it actually, first of all, it actually takes a lot to productionalize any kind of generative AI applications, whether it's like consumer applications or enterprise applications. And it's first principles of engineering still applies to any of the case if you were to ship something from a demo to a production. So that still stands. And then I would say I am, however, still very optimistic about this. I think there's huge potential, but there are certain quality hill climbing that still needs to happen, and that would mean a lot of resources we needed this to make it happen, including but not limited to like computing resources, like talent and like researchers, engineers, cross-functional talent, like product management and other aspects of things. So yeah, in short, I think I'm optimistic, but it's not like working 100% of the times, and yeah.
Great. Thank you so much for sharing.